So here what I'm doing is I'm looking at Borneo in Indonesia, and I can either select a shapefile, or I could use a drop-down menu where you have all the regions of the world, or draw a polygon. And I'm inserting a new data set. Here you can choose anything from a wide range of data set, including the Google Earth Engine catalogue. Here we're looking at Landsat. We're integrating the entire Landsat catalogue, and I'm focusing on the area that you can see here in the green. In this case here, I'm going to be looking at 2 years. I'm going to look at selecting all the imagery within the Landsat catalogue that covers the year 2021 and 2020. And that's because it's in many places in the world, it's a very cloudy environment. So we want to make sure we have enough of pixels or parts of the imagery that are not covered by clouds. Here I'm basically going to bin all the parts of the images within that collection that I've selected that have a cloud cover more than 70%. And now when I create a composite, I'm going to create a summary image, something that basically brings all the good pixels from all that 2-year period that has a very low cloud cover, so that I have the equivalent of a summary image. And I'm going to save this data set. So I've created, if you will, an optimum data set from that 2-year period. And I've saved this. And because I work as part of a team, I'm going to write my comments here. I'm explaining to the team what I've done here. I'm tidying up a little bit my workflow. Here we're going to integrate radar data. Radar data is really powerful because it allows you to work with structural information on the land. And here I'm looking at 1 year only because radar is not affected by cloud cover. So I'm going to create here again a composite image that brings all the information I have over a year. It gives me a lot of information about the structure and how it changes and the seasonality. And I'm saving this data set again. And I'm saving those 2 data sets because I'm going to use this in my classification, just so that I can, with as much accuracy as possible, identify and differentiate different land classes that exist in this area. Now that's the yellow block. In this case here, I'm looking at classification with, you can select various algorithms, but in this case here, we're leaving it to random forest. That's quite one way machine learning that will help classify the various land. And I integrate the 2 data sets that I created earlier on. I have training data that I'm uploading there, and then I'm bringing my outputs. In this case here, I want to start visualizing this. I want to see, well, what is my classification? Can I identify the villages and the areas where we have a confluence of different interests? I chose a palette here that allows really to visually differentiate between the different land classes. I'm basically tidying up here my workflow. I'm quite a tidy person, so I quite like when things are not looking too messy. So, I mean, this is a workflow that if you had to code this and do this from scratch, and downloading the images could potentially take a few days, right? And we've done this in a few minutes. And that's the power of Earth Blox, really, is being able to see and visualize and conduct analysis and prototyping things in minutes rather than potentially weeks or months if you don't know how to code. So what we have here is the dark green and the teal are the plantation areas, and the sort of lighter green is the more sort of natural forest. The yellow area and the orange are agricultural fields, and the villages and what I call more urban, but villages. In the dashboard, you have the confusion matrices, this sort of accuracy and all these things.